Hey guys, welcome back. So, in today's class, we would be talking about Kubernetes and the services it offer. So, in the previous lectures, we have launched pods and added self-healing and the scalability via replica sets, but we have explained that we can't rely on pod IPs. And in this lecture, we will see how Kubernetes services give us networking that we can rely on. So let's break the chapter in couple of different numbers. First is setting the scene, theory, hands-on, and real-world example. Now we will look at two typical access scenarios. Number one, accessing ports from inside the cluster and outside the cluster. Now setting the scene. Before diving in, we need to remind ourselves that pod IPs are unreliable. When pods fail, they are replaced with new pods with new IPs. Scaling up a replica set introduces new pods with new previously unknown IP addresses. Scaling down a replica set removes pods. This removes network endpoint from the replica set app. All of this means that pod IPs are unreliable. We also need to know three things about Kubernetes service. First, we need to clear up some terminology when talking about a service in this chapter. We are talking about the service REST objects in the Kubernetes API, just like a pod, replica set, or deployment. A Kubernetes service is an object in the API that we define in a manifest and pass to the API server. Second, we need to know is that every service gets its own stable IP address, DNS name, and port. Third, we need to know that a service uses labels to dynamically associate with sets of pods. The last 2 points are what allow a service to provide stable networking to a dynamic set of pods. Now let's quickly jump on the theory portion. If you see the figure, it shows a simple pod-based application deployed via replica set. It shows a client, which could be another component of the app that does not have a reliable network endpoint for accessing the pods. Remember that pods IPs are unreliable. Now, the same pod-based application with a service added into the mix can be written in this way as per the figure which you see on the screen. The service is associated with pods and provides them with a stable IP, DNS, and port. It also load balances requests across the pods. This means the pods behind the service can come and go as much as needed. They can scale up and down, they can fail and they can be updated, and the service in front of them notices the changes and updates its knowledge of the pod, but it never changes the stable IPs, DNS, and port that it exposes. Let's jump on to labels and loose coupling. Now, pods and services are closely coupled. While labels and label selector, this is the same technology and principle that links pods with replica sets. If you see in the figure an example where 3 pods are labeled as zone is equal to prod and version is equal to 1, and the service has a label selector that matches. The service shown in figure provides stable networking to all 3 pods. It also provides simple load balancing. Now coming on to the other aspect, for a service to match a set of pods and therefore provide stable networking and load balancing, it only needs to match some of the pods label. However, for a pod to match a service, the pod must match of all the values in the service label selector. If that sounds confusing, then let's discuss it a bit more. Now, let's consider an example where the service does not match any of the pods. This is because the service is selecting on 2 labels, but the pods only have one of them. The logic behind them is Boolean AND operation. Now, another example that does work, it works because the service is selecting on 2 labels and the pods have both. It doesn't matter that the pods have additional label that the service is not selecting on. The service selector is looking for pods with 2 labels. It finds them and ignores the fact that the pods have additional label. all that is important is that the pods have the label the service is looking for. So the following excerpts from the service YAML and replica set YAML shows how selector and labels are implemented. So if you see the examples I'm talking about, and this one. Yeah. So in the example file, the service has a label selector .spec.selector with a single value app is equal to hello world. This is the label that the service is looking for when it queries the cluster for pods. The replica set specifies a pod template with the same app is equal to hello world label, which is actually .spec.template.metadata.labels. It means that the pods it deploys will have the app hello is equal to word label. It is these two values that loose tie the service to pods deployed by the replica set. When the replica set and the service are deployed, the service will select all 10 pod replicas and provide them with a stable networking endpoint and perform load balancing. Service and endpoint objects. Let's discuss on this. Now, as pods come and go, scaling up and down, failures, rolling update, etc., the service dynamically updates its list of pods. It does through a combination of the label selector and a construct called endpoint object. Each service that is created automatically gets an associated endpoint object. This endpoint object is a dynamic list of all of the pods that match the service label selector. Kubernetes is constantly evaluating the service's label selector against the current list of pods in the cluster. Any new pods that match the selector get added to the endpoint object, and any pod that disappear gets removed. This ensures the service is kept up to date as pods come and go. Now, the endpoint object has its own API endpoint that Kubernetes native apps can query for the latest list of matching pods. Non-native Kubernetes apps can use the service virtual IP, which is also kept up to date. Now let's talk about accessing from inside the cluster. Now, when we create a service object, Kubernetes automatically creates an internal DNS mapping for it. This map the name of the service to a VIP. For example, if you create a service called Hellcat SVC, pods in the cluster will be able to resolve to the service VIP. Therefore, as long as you know the name of the service, you will be able to connect it by the name. Now let's talk about accessing from outside the cluster. We can also use services to access pods from outside the cluster. We already know that every service gets a DNS name, virtual IP, and a port. A service port is a cluster-wide, meaning it maps back to the service from every node in the cluster. We can use this port to connect to the service from outside of the cluster. Okay, let's take an example. Now, at the lowest level, we have nodes in the cluster hosting pods. Then we create a service and use labels to associate it with pods. The service object has a reliable port mapped to every node in the cluster. The port that the service uses is the same on every node. This means that the traffic from outside of the cluster can hit any node on that part and get through an application pods. Now let's take an example where 3 pods are exposed by the service on any port on every node in the cluster. In step 1, an external client hits node 2 on the same port. In step 2, it is redirected to the service object. This happens even though node 2 isn't running a pod from the service. Now, step number 3 shows that the service has an associated endpoint object with an always up-to-date list of pods matching the label selector. Now step number 4 shows the client being directed to pod 1, and that is what we want. Now the service could just as easily have directed the client to pod 2 or pod 3. In fact, future requests may go to other pods as the service load balances traffic between them. There are other options for accessing services from outside of a cluster, such as integrating with load balancers from your cloud provider. However, that starts getting platform specific implementation differences between Google and AWS, etc. And we are not discussing about that. So I'm taking a pause here, and ending this particular lecture. In the next lecture, we would be discussing a few more things associated with the same. So till then, thank you very much.